Everything is looking good, guys.
Thank you. A few more seconds here for a few more people to pop in, and then we'll go ahead and get started. It's 10:31, so I think we will get started. Good morning, everybody. Welcome to the Remote Experience for Young Engineers and Scientists program known as REYES. I'm Dan Gennard. I work at Old Dominion University, and I'm a REYES volunteer. I will serve as your host for today's lecture on the Introduction to Artificial Intelligence featuring Rajat Goel. Today's discussion offers us an overview of different concepts in AI and machine learning and how do they differ. Throughout this webcast, you may submit questions to the Q&A box on the Zoom screen. And following Rajat's lecture, we will answer as many of your questions as time allows. It's now my pleasure to introduce our guest speaker. Rajat has been in the software engineering industry for around 6 years, working in the fields of AI, machine learning, and natural language processing. After graduating from the University of Southern California with a master's degree in computer science in 2018, he developed various automation features for Autodesk products, Fusion 360, leveraging AI tools and technology. He also worked at Google, optimizing the bidding system for their ads infrastructure, working closely on reducing compute costs and enhancing advertiser budget spend through statistical models. Currently, he is working with IBM and is contributing to creating an NLP-based solution for automated order taking applications, which would be deployed in various restaurants all across the United States. In his free time, he likes to go for hikes, travel different places, and play his ukulele. Please join me in welcoming Rajat to REYES.
Thank you, Daniel, for the great introduction. Welcome, everyone, to this talk about Introduction to Artificial Intelligence. I wanted to introduce myself, but Daniel did a very good job. So I'll probably skip the slide. But yeah, a little about me. I came to the US in 2016 to pursue my MS in computer science from USC. Worked at Autodesk as a senior software engineer for 3 years. Thereafter, I joined Google, where I worked on optimizing their ad systems for 1.5 years. And then currently I'm working at IBM as a machine learning engineer, basically working on developing an AI agent that would automate the process of order taking at quick service restaurants like McDonald's. About today's agenda, we would be going over an introduction of artificial intelligence, what it is about, what development have been done in the past, and where we stand in the present. We would also get to know some types of AI systems and how do they differ. Next, we will be looking into machine learning, which is one of the most widely used AI system, and discuss various types of ML models and the process of creating and deploying those models in production, which are also known as machine learning operations or MLOps. After that, we would go over one of the most popular topics these days in AI domain, which is generative AI. We would be looking at some of its applications, and I would also give a very high-level overview of how it works. I'll end this talk by discussing why we should care about developing AI solutions, and gaining AI development skills, and we'll also give you some directions on how to get started in the field of AI by discussing some tools that are widely used in the industry. So let's get started. First, about artificial intelligence. Before we discuss any further about AI and various types of it, we really need to understand what AI is all about. Artificial intelligence, as the name refers, is basically inducing intelligence artificially. Now, we can induce intelligence into machines, which are considered dumb. But basically, it means that we want machines to mimic human mind. Why human mind? Well, humans are known for their brains. They are like most evolved species on this planet. And if we have machines that mimic human minds, we have artificial intelligence. But how do we know if someone is intelligent? Let's analyze that a bit. First, decision making. We as humans make decisions all the time, whether they are big life decisions like which college to attend or who to marry, or whether it's small ones like what to eat for dinner or what to watch on Netflix. There are a lot of parameters that we take into consideration before reaching any conclusive decision. If we want machines to mimic humans, we want them to make informed choices. Next, problem solving. Let's discuss about learning to drive a car. That itself is a very complex problem to solve. When we are learning to drive a car, there's a whole lot of things that are going in and around the car, a very dynamic, evolving environment that we are in when we are driving the car. We have to decide when to stop. We have to know how hard to brake. We have to consider how hard to accelerate when we are around school area or versus when we are ramping up on a highway. All these things require a lot of attention, a lot of optimization and heuristics when we are considering solving this kind of driving problem. A dog, which are quite intelligent in my opinion, cannot do all this. So for AI to be intelligent, it should know how to optimally solve complex systems and complex problems by applying knowledge it has learned. Next important trait is communication. This is one of the important capabilities that humans differ from other species. We have developed a very systematic way of communicating with each other through languages. We not only convey our emotions like other species do, but we can also convey abstract ideas and arguments and discuss those arguments through speech and writing. This is very unique to humans. That's why we want AI refers to as like machine's ability to mimic human mind. If we are developing an intelligent system, communication would be another trait that we should be looking for. Last but not the least, creativity. Another characteristic of intelligence is creativity and innovation. Humans can produce novel solutions, identify alternatives, and we can also challenge conventional ideas. This is a very, very peculiar trait of intelligence. And if an intelligent system, let's say, can make decisions, but cannot adapt, it can solve problems, but cannot identify or generate new problems. It can communicate well, but cannot generate new ideas. Would you rather consider that as an intelligent system? Well, that's another discussion, I guess. But how do we make machines to learn all these qualities and traits? Well, they learn through data. Very, very much so how humans learn in their childhood when we are like growing. We basically observe the environment and observe the world around us. Machines also learn through the data that we have gathered about the world that we are living in. Consider it like an AI school where machines go to learn how humans behave, but can absorb knowledge much quicker. And finally, we have an intelligent system which is artificially made from humans. Let's look at some examples of AI systems that we see in our daily lives. Voice assistants. You must have used Siri or Alexa or Google Assistant. They are much more capable of understanding human language. They can communicate in a human-like way, and they can also make decisions based on their understanding of our instructions that we give it to. They are, however, limited in problem solving and creativity. We can communicate with them on a one-on-one basis, but if they are given some problem or a puzzle, they might not be able to solve, and they do not generate new data. Next, self-driving cars. As I mentioned earlier, driving a car is a very complex problem, which involves a lot of variables in and around the car itself. Autonomous driving agents is one of the most researched and popular fields in the industry nowadays. There are a lot of companies that are investing into autonomous vehicle driving, not only traditional ones, Toyota, Mercedes, but also new industries are emerging out of it, Waymo, and others. The agent needs to be very quick in solving the problem and also needs to have very fast response times after a decision is made. Now you can imagine like how optimized this technology should be. But they still have a limitation. They cannot communicate or be creative. Next is generative AI like ChatGPT, which is being widely used by many of us. We can make prompts to AI to generate us new data. This data could be text, like in the example of ChatGPT, but it could also be images or code or even new TikTok reels. This is another popular area where a lot of innovation is happening these days, with companies like Google and Adobe coming up with their own versions of text and image generators. Now that we have discussed some characteristics of intelligence, and let's assume we have a system that has all these characteristics. It can make decisions, it can solve problems, it can communicate well with the humans, and it's also creative. How do we measure AI against human intelligence? For that, we have to go in the past, where a computer scientist named Alan Turing proposed a test in 1950s. This test was to measure a machine's ability to exhibit intelligent behavior. The proposal was that we have a human judge engaging in a natural language conversation with both a machine and another human without knowing which is which. If the judge cannot consistently differentiate between the machine and the human, the machine is considered to have passed the test. The purpose of this test was to assess machine intelligence by evaluating its ability to mimic human-like conversations and behavior, and also to determine if a machine can demonstrate human-level intelligence. In the field of computer science, it serves as a benchmark for computer scientists for evaluating the progress of AI, and particularly in natural language processing and human-like conversations. It has sparked multiple discussions and debates about the nature of intelligence, what intelligence is all about, and the possibility of machines to achieve human-level cognition. However, this proposed test to measure machine intelligence is limited in its scope to language-based communications. Think of like generating images. How would you know whether you're interacting with a human or a machine? For the rest of this talk, let's extrapolate this test to generalize the idea that if we interact with a system that gives us a response, and if we cannot decide if the response came from a human or a machine, we have an AI that has human intelligence. Now the question comes up, are we there yet? I'll let you watch this video from Vox and we'll let you decide by yourself.
You're called to create.
A post-apocalyptic giraffe astronaut generated. Genghis Khan playing a guitar solo. Pixel art generated. A man holding a delicious apple. What's with his hands? Why can't AI art make hands? It doesn't matter what AI art model you use. If you have a man holding a delicious apple, his hands will look weird holding it. Why is this so hard? Seems easy enough, right? We've got this weird situation where AI art can instantly make Abraham Lincoln dressed like glam David Bowie, but struggles with a woman holding a cell phone. This isn't just a weird glitch. The struggle of AI art with hands can actually teach you something bigger about how AI art works.
Well, the question still remains, are we there yet? Probably not. But this video is very interesting to discuss what AI is capable of and where it fails. It also discusses how AI learns to generate art and why it cannot learn what hands do to humans. So I would definitely encourage you to watch this 10-minute video later after this talk. It's available on YouTube on Vox's channel. Let's discuss some history of AI systems before we delve deeper into AI, different kinds of AI systems. Let's see where we are coming from. So as we discussed earlier, in 1950s, the idea of artificial intelligence was first introduced by Alan Turing through his paper, which raised the question, can machines think, and proposing the famous Turing test. After nearly 3 decades in 1980s, the concept of machine learning evolved, where systems were trained on multiple data sets to learn patterns and make predictions. As the compute resources evolved with cheaper CPUs and faster GPUs, deep learning became more popular in 2010s, which is a subset of machine learning where we have complex artificial neural networks that learn nuanced patterns in images and speech. Now, when you are considering image and speech, that data is very vast and varied in terms of how much things it consists of. Consider like 64 by 64 image, which has lots of pixels. This was possible through their deep neural networks and layers of neurons, artificial neurons that the layers have. Now, most recently in 2020s, generative AI was popularized primarily by OpenAI's ChatGPT, as we all know. There is also DALL-E, that is OpenAI's system for generating art, as we saw before. These systems are based on transformer models that would learn to mimic human behavior and generate text and images from some prompts. We'll discuss more about this in the talk. Now let's dig deeper on how AI systems are created. For that to understand, let's discuss how we could learn to differentiate shapes. Now let's assume that you do not know anything about circles or rectangles or triangles. If I would want to learn different types of shapes, there are basically 2 ways to do it. The first way is rule-based, where we define what a triangle is, what a rectangle is, what are the properties of a circle. Let's say I say that a triangle has 3 sides, a rectangle has 4 sides, and all the adjacent sides are at 90 degrees. A circle has a center and a radius, and so on. So when next time a shape comes to us, we would evaluate that shape against the properties that we have defined and decide if it is a triangle or a rectangle or a circle. So in a rule-based system, we define rules and business logic And the systems would learn to recognize patterns and make predictions based on these rules. These systems, although deterministic, may be hard to program. And sometimes it is difficult or nearly impossible to come up with appropriate business logic around the data that we have. Next is machine learning based systems. So another way is to learn shapes is if I would give you a lot of examples of triangles, rectangles, and circles. When I give you a shape, I say this is a triangle or this is a rectangle. You would automatically learn how triangle looks like. You may also come up with your own rules. Saying, let's say, if a shape narrows down to one single point, then it's a triangle. So next time when I give you a triangle and ask what it is, you would immediately go back to the shapes you have learned through examples I provided you and would recognize that this is a triangle. Machine learning systems learn through examples as well. We provide them labeled data to learn their own pattern and make their own rules without us making the rules for them. Even though they're easier to program and train, these systems can get easily affected by biasness in the data. And they're also very limited in recognizing patterns for the data that they're trained on. For example, what happens when I show you a trapezium in the above example? Well, our system has not learned how to recognize trapezium, so it would either predict a rectangle or something. But though that's the limitation of machine learning systems, that we have to gather a lot of data that is more varied in nature and is more spread out. Some examples of rule-based systems are chatbots used in customer service systems. These systems use predefined rules to understand customer queries, categorize them, and provide relevant information, or direct them to the appropriate department or resources. Very similar to what various companies have for their IT departments or HR departments. Next is game-playing agents. Games like chess and Go have game rules that the agent learns and uses advanced decision tree-based algorithms to evaluate the next best move. Fraud detection systems in financial world, the fraud detection systems are also rule-based systems. These systems employ predefined rules to analyze transactional data and identify patterns that indicate potential fraudulent activities. Rules can include thresholds for unusual transactions, suspicious patterns of behavior, or known fraud patterns. So next time, if you make, let's say, like $2,000 purchase, where you usually make $10 or $20 purchases, that's what the suspicious behavior is. In supply chain management, a rule-based decision support system can suggest optimal inventory levels based on their predefined rules, considering various factors like demand, supply, cost, and stuff like that. Automated trading systems also employ rule-based systems where in financial trading, they have predetermined rules of buying and selling various commodities in the market. These systems are based on rules such as technical indicators or market trends or trending strategies to automate the trading process. So basically, we have an inference engine where we supply the rules and the data to train. And then next time when a new data would come up, we would set that against the rules that we have trained on and then give the solution. That's the basic idea of rules-based system. Some examples of ML or machine learning-based systems is email spam detection, which employ classification models that would learn if an email is a spam or not spam based on historical email data that we have annotated as spam, much like the example that I gave about a lot of examples of shapes. Market segmentation. This is used by many companies to target customers and develop marketing strategies. They basically have customer behavior data that they have logged through the business transactions that they made through their business. and they create categorization models to identify patterns and segments in the market, so that it can help them better identify how to better target their customers. Voice assistants, as was discussed before, learn to understand and communicate in one or more languages by analyzing a large data sets, and learn how humans speak and talk. They learn many aspects of communication like intonation, hesitation, context, sometimes sarcasm, and various human emotions, like when I'm talking sadly or disappointingly, or when I'm too excited, something like that. Generative AI, like ChatGPT, learn the language itself, and creates new sentences and text based on its understanding of what each word means and how sentences and paragraphs are created. Now that we understand what machine learning based systems are capable of, how these systems create better understanding and pattern recognition through self-learning rather than human programming, it would not be fair if we do not discuss about machine learning in more detail. So let's dive deeper into it. Well, the question comes up: how do machines learn? Let's watch this video of like how a baby learns to differentiate between shapes. Well, this baby was more intelligent that our system could be trained on recognizing shapes by simply forming hat out of basket. But I wanted to divert your attention within the video of like how child learns to recognize shapes by trial and error. It tries to match each block with the shape it fits in. We also see him rotate the shapes few times to match with the shape within the box that it has to go in, which helps him to learn how orientation of the shape is all about. Machines learn in the same way when they match the pattern with a given data set to certain features that we have trained it on. Let's see how. So let's discuss about various ML methods or ML models that we have at our disposal. The first one being supervised learning. In supervised learning, we train our model on lots and lots of label data with similar example of like identifying shapes, where for each shape, we have told that like this shape is triangle, this shape is square, and we learn a mapping between the input features and their corresponding labels. So basically creating our own mapping or like rule of identifying each shape. Next is unsupervised learning. This is another category of machine learning models, but these are trained on unlabeled data. So we have all sorts of examples of shapes, but we do not know which shape is which. And when we are training a model on unlabeled data, we basically, the purpose of training is to discover various patterns and relationships within the data. So consider it like a categorization model, very much similar to market segmentation. We also have recommender systems, which falls under supervised learning, where you basically on Netflix, when you watch a show, it stores your watch history, and based on your watch history, it would recommend that, hey, you have watched this show. This is very similar to it. Would you want to watch this new show? Something like that. Next category is reinforcement learning. here, the agent learns to interact with a new environment, and it takes actions to maximize a reward signal. Consider it very much so like training a dog. You have to give them treats, or in this case, sometimes punish the system and say that, hey, you are doing it wrong versus you are doing it right. And then by trial and error, it would learn eventually on how to like solve a problem. It's very much similar to how we solve a maze puzzle. We would go in one direction and then get a blocker and then come back, trace it, and then go back again with another direction. That's how we know that we are learning to come up with like a new solution. Last is another category, like one of many. These are just 4 major categories that I've discussed, but there are a lot more than this. But last one is self-supervised learning. Here, we provide a lot of unlabeled data to the model to train from, but it not only identifies the pattern, but it also creates its own pseudo labels for training. So let's say if I have given you a lot of examples of shapes, I would try to label each shape as like either a triangle or a square or some other, like some label, which is mostly numerical, 1, 2, 3, 4. An example would be large language models, which are widely used in how ChatGPT is trained. We basically categorize shapes and then label it and then learn the rules around it. So it's a bit of a combination between supervised and unsupervised, but yeah. Next, we discuss once we have machine learning models that are trained on various amounts of data, how do we come up with a solution that employs a machine learning solution? Let's discuss about various operations in developing a machine learning solutions. The first one being data discovery. So in step, we discover, go out in the world and try to identify what could be various sources of data that we can get the data from, which is related to the business problem that we have. Next step is data preparation. In data preparation, once we have gathered all sorts of data, we have that data from various amounts of sources. We want to collate that data. We want to clean that data. Let's say if the data has some missing fields, or if the data is not in an appropriate format, then we basically clean and extract the data appropriately. We apply some privacy filters where we are removing all the private information, SSN numbers, passport numbers, etc. And we also apply some censorship. So if we go to ChatGPT and prompt some explicit content, then it would basically refuse. So that's what censorship and data preparation is about. Next step is training and testing. So once we have identified the data, we have cleaned it, we want to train a machine learning model against that data. We experiment with different kinds of model configurations, tuning hyperparameters. So hyperparameters are basically, you can consider them as like seeds to the model. And we measure accuracy against some test data. So we basically segregate the data into 2 parts, training and testing. And then we do not train our model on testing data, but we measure or evaluate our model against that. Last part is deploy and monitor. So once we have trained a model, we are happy with the accuracy of it. We ship the trained data for deployment so that it can infer on a real-time basis with new data that is coming through. We also monitor its accuracy continuously, the latency of inference, and if there are any model failures, or let's say if the model is offline and we are getting a lot of errors and reports around it. So that's basically the whole life cycle of creating an ML solution end-to-end, from identifying a business problem, deploying a solution in production. Now let's talk about generative AI and what it is all about. Some of the examples of generative AI, as you might have heard of, is generating art that we've seen in the video. So this example is from OpenAI's DALL-E model, where we have a prompt about an armchair in the shape of an avocado, and it generates different images based on its understanding on what chair is, what avocado is, and how I can formulate a chair based on a shape of an avocado. Another example, which is more text-based, is ChatGPT. I've just added like one of the prompts that I was experimenting with earlier. It basically understands what Draco Malfoy is, what Harry Potter is, what is the context behind it. Well, there are novels around it. And then it also understands the nature of Draco Malfoy and Harry Potter. And then it also understands what greeting means. And if they're meeting for the first time, how, like, what the tone should be of greeting based on Draco Malfoy's nature. So a lot of things going on in the simple prompt as well. Some of the applications of generative AI, we have visual generators like image generator, video generator, and UI UX generator. So we can basically design logos or websites and stuff like that. We have audio-based generative AI, which generates speech and music. We have language-based AI, which is much more like ChatGPT, where we generate text, we create translations. We also create summarizations around, let's say, if we have like a whole lot of prose, we can summarize text, or we can summarize meeting notes or email threads. So a lot of solutions going on in the market right now around that. Next is software. Software-based AI like code generators or data simulators are also becoming popular. GitHub's Copilot is one of the examples there. Virtual reality. So Apple has very recently released Vision Pro, where you can basically create your own world behind the scenes. You might have also heard of Oculus, which is another form of creating a metaverse and experiencing it. So basically, an AI could generate new experiences around like a whole different worlds altogether. And we can also create video games. So basically, game playing and different characters, those kind of design would also be possible by generative AI. Let's get a bit technical about like how it works. I would want to give you an overview of like how GPT or ChatGPT works. So GPT basically stands for Generative Pre-trained Transformer. So it's a pre-trained model which is generative in nature, and it is based on transformer-based architecture. Now, what is transformer-based architecture? So let's go step by step. The first step on a text-based GPT is we convert each word into a numerical representation, which are called embeddings. So this is how we learn the language. We first understand what words are, and then we basically try to come up with our own meaning of words. So in order for computers to understand, we want to convert each word into a numerical representation. We add a positional information of each word in the sentence. So like that's how we learn what adjective is, what noun is, what verb is, and where do they fit like in relative position to each other. Third step is self-attention mechanism. It's basically a fancy term to say how we weigh importance of different words against other words in the sentence. So if we have a noun, let's say if I say Abraham Lincoln was a president of the United States, then Abraham Lincoln would have more weightage than is or the in the sentence. We then refine and transform the representation that we have learned through neural networks before generating any output. So we fine tune our learning based on neural networks and identifying various patterns within the language so that we can understand a bit more before generating any output. And then when we have created this architecture, we train it on a very large data set. That's how we create a large language model, and we use reinforcement learning to learn from that data set, saying that, hey, this prompt was good, but it could have been better based on more reward, or like we assign more reward to a better prompt or better response to the prompt. This is the visual representation of what I have been saying. This I have taken from LinkedIn from one of the authors, Ivan Dunbar. This is just a sentence where it visualizes how each word is weighed against each of the other words in the sentence. You can notice how law is related to perfect and which is the law. And then you can also notice how missing is related to this is what we are. And then right after missing, there was a comma. And that's how the agent understands, or the AI understands, that we have a separate phrase within the sentence. I have a few more slides left. I know I'm on time, but we'll be very quick in going through it. So let's talk about AI development and why it is important. So I have taken this data from McKinsey's AI adoption report in 2022. As we can see, AI adoption in businesses has increased over the past few years, with many more companies open to considering augmentation of AI processes in one or more of their business units. Chat agents in IT department or HR related issues are most common use cases in the industry. And AI adoption is 2.5 times higher today than in 2017. Here we see that the number of AI capabilities such as robotic automation, computer vision, natural language understanding, etc., has doubled over the past 5 years from 2018, where we have on an average 1.9 capabilities included in one of the business units. We now have 3.8 capabilities on average in at least one business unit within the organization. This one is interesting. So the level of investment in AI has also increased alongside with adoption. So more and more businesses are not just leveraging AI solutions, but they're also investing more money into developing those solutions or adopting those solutions. So as per the study, the number of respondents that reported more than 5% of companies' digital budget went to AI has dramatically increased from 40% in 2018 to 52% in 2022. This is 12% of the businesses. 12% of businesses have already increased their investment in AI, which is huge. With these results, they were from 2022 report. There is no denying that businesses are openly accepting to leverage advantages of AI in their business, and the demand for AI-based skills will only grow from here. So now that we know why AI is important and why developing those skills is important, I want to give you some tools to get started, and we'll go over it very quickly. The first one being TensorFlow. It's an open source machine learning framework which was developed by Google. It provides a comprehensive ecosystem for building and deploying AI models. The machine learning models that we have discussed so far, you can basically create your own machine learning models, train them on your data, and then build and deploy it for businesses or for your own purpose. They support various tasks like image classification, natural language processing, reinforcement learning, and you can also create your custom models and fine-tune it based on your use case. Next is PyTorch. PyTorch is another widely used open source machine learning framework, which was developed by Meta AI. It offers a dynamic computational graph and is known for its user-friendly and intuitive interface. It gained popularity for research and rapid prototyping due to its flexibility and ease of use. It's very similar to TensorFlow, but it's more intuitive in nature, and you have like more solutions out of the box. Scikit-learn is another well-documented Python library. It provides not only creating ML solutions, but also supports data processing, model selection, evaluation, and monitoring around it. And it offers a very straightforward API and is very well suited for beginners to start with AI development. Next is Pandas. Pandas is a library which is popular for data manipulation, analysis, and preparation. It provides high performance and easy to use data structures and data analysis tools. It's a very easy AI like every AI application would need some data ingestion, and Pandas offer multiple ways to optimally source, store, and visualize the data. Cloud services like Amazon Web Services, Microsoft Azure, Google Cloud Platform. They offer a suite of tools and services for AI and machine learning development. They provide capabilities for training and deploying models and managing data pipelines. You can also automate various machine learning workflows, and they even integrate with like popular frameworks that we have discussed before, TensorFlow, Scikit-learn, and others to offer scalability and ease of use. Last that I have on my list is Jupyter Notebook. Jupyter Notebook is an interactive development environment that allows you to create and share documents containing live code, visualization, and explanatory text. It is widely used in AI development. Even in general rapid prototyping, you can use it. You can basically plug and play things, use different kinds of Python libraries within Jupyter Notebooks for data exploration, model experimentation, and documentation. When you would work on it, you would see that it has like separate blocks for code and text, which can be run as needed. And it offers rapid prototyping and ease of sharing over channels like GitHub. Now that you have all the knowledge and resources of creating an AI-based solution, I encourage you to learn and grow your skills in the field. I am every day fascinated by various things an AI could achieve to help build a better society and assist people in the ways that were never imagined before. Thank you all for letting me give you a gist of what AI is about. I hope I was able to help you understand what goes behind developing an AI solution and motivate you to explore more. With this, I open the floor for any questions.
Great. Thank you, Rajat. That was really a great presentation you did. So thank you for that. We've had some questions come in to the question and answer chat. So let me send a couple of those your way. First one, what is the capacity of ANN or artificial neural networks compared with the human brain? And has ANN already surpassed the human brain, or is it likely to do so in the next couple of years?
Yeah, that's a very good question. So you have to understand that artificial neural networks try to mimic human brain, but they do not work as human brains do. They have given this fancy name to neural networks, but it's just a whole lot of mathematics that goes on behind the scenes. Human brains are much more capable of understanding emotions, which cannot be quantified, I believe. They are also better in understanding like how to deal with dilemma, ethical problems, which AI is not capable of at this point. For the capability or like the extent of how big the artificial neural network could be, you need to understand what each layer within the neural network does. For that, you need to visualize the data after it has passed through each layer. So an example would be when you are developing a deep neural network for classifying images. At each layer, you would see that the artificial neural network is able to identify different characteristic of the image. Let's say in one of the layer, it identifies the edges. In another layer, it identifies the depth. In another layer, if we are classifying human faces, it could identify what nose is, what eyes is, what mouth is. Those kind of characteristics could be identified in each of those layers. So it's difficult to mimic like human brain from like artificial neural network in general, I would say, but for like developing the characteristics that we discussed about making decisions, problem solving, creativity, communicating, those are the things that we can achieve through artificial neural networks even today.
Which AI application are you most excited about and you feel hasn't been well explored yet?
Yeah, so I was very recently reading about the capabilities of what ChatGPT could do. I'm very excited about this technology just because it's something that that explores like new worlds or like new applications. So if you would imagine like ChatGPT prompts that were coming on the internet where it cannot solve 2 + 2. Well, ChatGPT was not trained to do it. It's not a mathematical model to solve mathematical problems, but we can plug like other models that we already have in existence to basically create like a human-like experience where, let's say, I ask ChatGPT what is 2 + 2, and the ChatGPT goes with that problem to another model, comes up with that solution, and then gives me a response that is more human-like, rather than just say 4, or that's just a very vague example. So I'm very excited about like creating like foundational models around technology like ChatGPT or like transformer-based models. And then from those foundational models, how we can evolve or leverage those foundational models, fine tune it based on use cases, and then create like a more holistic application, if I would have to say. So that's something that I really want to see where we take it to.
Right. So do you think that it's going to be necessary for us to create laws and policies around the use and implementation of AI?
Yes, for sure. And companies are and like engineers and researchers that are developing AI-based solutions are very much concerned about ethical AI, responsible AI, and governance around AI. I didn't cover that topic in my talk, but it's a very important topic, and thank you for raising that, whoever that was. But it's a very hot topic. When we are developing an AI-based solution, we need to make sure that we are not taking any undue advantage of the data that we have available to train the models. We also need to make sure that the AI is interacting with humans ethically. And I think there have been instances in the past where Microsoft has launched its bot on Twitter. I know of that news that like it launched the bot, and then the bot basically learned a lot of things that humans say in general on Twitter. And it started like giving all sorts of abusive language, and they have to pull the plug on it. So we like right now we are in that experimentation phase, but we have to make sure that we develop some kind of governance around developing AI and not let it go berserk.
With quantum computing in the news, do you think we will have machine learning algorithms in that field? And if somebody wanted to pursue that as a career option, quantum machine learning, what path do you think they should take?
Yeah, that's a very interesting question. I haven't really explored much into quantum computing, to be honest. But I believe that with quantum computing in picture, as with GPUs, when they came into existence and were very approachable to general engineers and scientists, I think quantum computing, when it has evolved enough to apply to machine learning applications, that would also be another revolution in training the models much faster and developing AI solutions quicker, maybe more efficient. For pursuing a career path, I would recommend like exploring what quantum, like where quantum computing stands today, and then how we can be more involved in its research. And I'm not sure if there are any applications of like machine learning based quantum computing solutions these days, but that is something that I would definitely look into.
So one of our participants wrote they're interested in knowing your opinion about this doomsday idea of AI developing beyond our control, and do you ever think it's going to happen?
Well, that's $1 million question that everybody is exploring. So, well, if it depends on like what path we choose, and I think that a lot of people are concerned about creating a responsible AI, and before that happens, there will be a lot of people that would raise that concern, and I hope that they win in this battle. So that would be my answer, but we'll see what future holds.
Right. And related to that, somebody else asked, do you think that it would be useful to have something like Asimov's 3 laws of robotics applied to AI?
I'm sorry, can you repeat that question?
Do you think it would be useful to have something like Asimov's 3 laws of robotics applied to AI? So that's,
Okay.
A robot may not injure a human, robot must obey orders given by human beings, that type of a thing.
Yes, definitely. I think a lot of AI that is being generated at this point is more assistive in nature. So basically, it is not taking over humans. Like I get this question a lot of times since I'm developing an AI agent that would be taking orders at the restaurants. Would it replace people in the restaurants? The answer is no. We are developing an AI which is more assistive in nature. So I guess a lot of people that are creating AI solutions is to assist people in creating or like having better experiences, or like solving problems faster, or taking advantage from AI, versus AI doing all sorts of things that like it would at some point it would replace humans. I don't think we are going in that direction at this point. And if there are experiments that go in that direction, we are very quick in killing those experiments. So yeah, I think for the laws of robotics that I am not familiar with, I'm sorry about that. But since you explained, Daniel, I think it's very, like right now we are very careful about developing such solutions, and I think those laws would definitely be considered while developing such solutions.
How can we be sure that when we're training these models that we're using good and fair data? Since it's human beings who are providing these ideas and concepts, just how can we make sure that we're giving these models the best data that we can?
That's a very good question. I think that's something that's another area of exploration that companies do in general. There are a lot of tools where you can see how normalized the data is, what the spread of data is across different features. And even after doing all that pre-processing and identifying like how vast our data is and whether it has some biasness or not, we still experience some biasness of the model versus the other. And I think there is a very fine line of trying to make machines intelligent and mimic human mind and not be biased, because humans in general are biased. And since the models are trained on data that is generated by humans, it is difficult for machines to understand whether it has to be biased or not to be biased. But to create a non-biased AI solution or like machine learning based solutions, we have to make sure that we are training the AI on different kinds of data. I think very, very good example that we saw was how Google was developing this face detection algorithm where the face detection within Google Photos was much better when it would detect a face with fair skin versus a darker tone in the skin. So they basically included a lot more data of darker tone skins to identify the faces better. And it not only enhanced the model to identify faces better, but it was also deployed to improve photos in lighter, like darker lighting conditions. So it was just a win-win for them.
Great. Well, that is time, everybody. We're at 11:30. I want to thank Rajat for his really stimulating conversation on AI, and I hope everybody got as much out of it as I did. And we look forward to seeing you in future REYES sessions. Thank you again, Rajat, for your time.
Thank you, Daniel. Thank you, everyone, for joining in, and I hope you enjoyed it. Thank you.
Have a great day.
You too.